Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the programs related to 8051 microcontroller under the course Microprocessor and Microcontrollers. The slides are prepared by referring the textbook, the 8051 microcontroller. Authors Kenneth J. Ayala. Publication Singh's Learning. The first program is develop 8051 program to move a block of data from external program memory to external data memory. So for 8051 microcontroller, we have external memory. We want to move a block of data from one point to another point. I'll take this one as a source location and these are destination location. So the microprocessor or microcontroller, whenever they want to transfer the data from memory to memory, the data first it will be fetched from the external memory to the microcontroller. Then what are the data which it is read, which will be stored in internal memory. Once the data is copied into internal memory, from the internal memory, the data will be stored in the destination location. Now we'll see the programming for this. First, we will load the R7 register with how many number of memory locations data transfer we want to take. That number of memory locations data we are going to be loaded into R7 register. Next, the address of the external memory. Whenever we are accessing external memory, the address we have to load into DPTR. So the starting address from where the data has to be fetched, that location address we are going to be placed into DPTR. So this is external memory. Whatever the source string is there, the starting address some XYZ, this we have to load into DPTR. This is external memory. Next, in 8051 microcontroller, we have the internal memory. This internal memory, the starting address, we are going to be load into R1 register. So for that, you will write move R1 comma hash internal memory. So the address of internal memory will be loaded into R1. Next, the contents of the external memory will be read by the microprocessor by using MOVX instruction. MOVX is for collecting the data or moving the data from the external memory or to the external memory. So here we are reading the data from the external memory. So we use MOVX from the external memory. So on right hand side we are going to have the address which is in DPTR. At the rate of DPTR will be refers to the content. That memory contents will be loaded into accumulator. Accumulator is the internal register of 8051. In the next instruction, this accumulator contents will be loaded into memory. So for that you will write move the address of this memory location we are going to have in R1 register. So at the rate of R1 comma A. So the contents of accumulator is loaded into the memory location which is pointed by R1 register. So here these three instructions or these two instructions will fetch one data from the external memory to accumulator, from accumulator to internal. So this it has to be iterated, depends upon how much count we are loaded into R7 register. So for every iteration, we are going to decrement the count. Next, for advancing to the next memory location, the DPTR value we have to increment. Similarly, for addressing to the next memory location, R1 we have to increment. So first we will increment DPTR followed by R1 increment. Then we will decrement the count which is in R7. If count is non-zero, go for repeating, collecting the data from external memory to accumulator, accumulator to internal memory. Increment DPTR, increment R1, this will points the next memory locations. As one transaction is done, we will decrement the count in R7. If it is non-zero, go to loop 1. So this loop will be iterated, depends upon how much count we are having in R7. After executing till this portion, the contents which are there in the source location of the external memory will be loaded into the internal memory of 8051. But here the task is we want to copy the data from external memory from one address to another address. So now the data is copied from external memory to 8051 microcontroller. Now we want to copy the data from the internal memory to external memory again. We will load again how many memory location we want to transfer, that will be loaded into R7. The starting address of the internal memory load into one register. External memory, the starting address we will load into DPTR. So move DPTR comma hash to address into which address we want to load. That address we are going to be load into DPTR. Next, the internal memory address we are going to be load into R1. Now the data transfer is from 8051 microcontroller to internal memory to accumulator, from accumulator to DPTR. So first, for internal memory, we use move instruction. Move at the rate of R1, data will be loaded into accumulator. So we'll write the instruction move A comma at the rate of R1. So internal memory contents will be loaded into accumulator. Then this accumulator contents we want to move to the external memory. For moving to the external memory, we are going to use move X instruction. So move X at the rate of DPTR comma A. Next, for pointing to the next memory locations, increment DPTR. For internal memory, increment R1. As for each data transfer, we have to reduce the count. So we will go for decrementing R7. This will be repeated until R7 content is non-zero. So if R7 is non-zero, go for copying the data into accumulator from the internal memory, then from accumulator to external memory. So these two instructions which are having for data transfer will be repeatedly iterated, depends upon R7. So once all the data are copied from the internal memory to external memory, we can terminate the program. Now we will see the entire program at a glance. First we will load R7 with the number of memory location. The external memory starting address will be loaded into DPTR. The internal memory address starting address is loaded into R1 register. Then we will extract the external data into the accumulator by using MOVEX instruction. MOVEX A comma at the rate of DPTR. Now accumulator contents will be loaded into the internal memory by using the instruction move at the rate of R1 comma A. As one memory contents are accessed, for pointing to the next memory locations, both internal memory, external memory addresses we have to increment, which are there in DPTR and R1 respectively. For each data transfer, the count which was specified in R7 register, that we have to reduce by 1. So for that we go for decrementing. Once the content of R7 is decremented, then we will check for whether it is non-zero or not. If it is non-zero, go to loop 1. So this loop will be iterated depend upon the count which was specified in R7. Till this point, the contents from the external memory is loaded into internal memory. Our task is to move from external memory to external memory. So in the next section, we will write the program for internal memory to external memory. So for that, first we will load the number of memory locations into R7. To which address of the external memory we want to load, that address will be loaded into DPTR. The internal memory where the data is residing in the internal memory, in the address is going to be loaded into R1. First we have to load the internal data into the accumulator. For that we use the move instruction A comma at the rate of R1. Now accumulator contents we have to move to the external memory. For that we use MOVEX instruction to the address which is pointed by DPTR. So at the rate of DPTR comma accumulator contents. So as one data transaction is done, we have to advance to the next memory location. So for that we will increment both DPTR as well as R1. For each data transfer, the count which you are there in R7, that will be decremented by 1, and the loop will be iterated until the count in R7 is equivalent to 0. So if it is 0, the condition fails, it will come out of the loop. The next instruction is use push instruction to put the numbers 82H in the RAM location 34 to 37. Here from 34H to 37 location, each and every memory location we want to write with 82, 82, 82 like this. Also write the same program without using push instruction. So push is always related to stack memory. So in the method 1, we are going to use push instruction. For that we use the stack pointer. So the stack pointer will be loaded the previous memory location address, that is 33H. Then whatever the data which we want to move, that data we are going to be stored into the internal memory, which is 50H in this example we are taking. Next, how many memory locations we are accessing? 34, 35, 36, 37. So total 4 memory locations we are accessing, 34 to 37. So that count we are going to be loaded into R7. The data which is there in 50H location, that we are going to be loaded into 34 to 37H. The data which is there in the 50th location, these contents we have to load here. So for that we use move content of 50H location onto the top of the stack by using push instruction. Push 50H. So the content of the 50H location will be loaded into stack memory. Next, as we want to move for 4 memory location, for each memory transaction, the content of R7 will be decremented by 1. If it is non-zero, go to loop 1. So here the stack pointer is having the address, starting address is 33H. So the entire program we have shown at a glance. Origin 8000H. So this is a directive to indicate where the program has to reside. So at 8000H, the program we are loading. So move stack pointer with 33H. The data whichever you want to load into the memory locations will be loaded into 50H. Then move R7, 04. How many memory locations we want to transfer, that will be loaded into R7. Every time you will push the 50H location contents into the top of the stack. For every transaction, R7 will be decremented. This will be continued until R7 is non-zero. Once R7 is 0, all the transactions are done. So we can terminate the program by using halt instruction. Next, the same program where we want to copy the data from 34 to 37 with the 82H. But here we are not using push instruction. So without stack memory, we want to update. First, we will load R7 with the number of memory locations, that is move R7, #04H. The address, that is starting address of the memory location, we are going to be load into R1 register. Next, whatever the data which you want to copy, that will pass as immediate data. So 82H will be loaded into the memory location. As it is internal memory, we use move instruction. So 82H will be loaded into the memory whose address is in R1 register 34. Next, we want to advance to the next memory location. So we go for incrementing R1. So this number of transactions will be depends upon what is the count we are having in R7. So for every transaction, R7 will be decremented. If R7 is non-zero, then will be go to loop 1. Where loop 1 again fetch the data into the memory location, advance to the next memory location. So this loop will be iterated until R7 is equal to 0. Now we'll see the program at a glance. Move R7, 04, number of memory locations. The starting address will be loaded into R1 register by using move R1, #34. Then immediate data, that is 82H, will be loaded into the memory location by using the instruction move at the rate of R1, 82H. For advancing to the next memory location, R1 will be incremented. As one transaction is done, we will decrement R7 register. This loop will be iterated until the R7 is non-zero. Once it is R7 is equal to 0, then we can stop the program by using halt instruction. The next program is write a program to compute a sum of n numbers and save the sum at 70H. So we will give a value n. We are going to add all the entities and the sum we are going to be loading to 70H. So first we will clear the accumulator as well as R0 register. For that we use the instruction move R0 comma hash 00 clear A. Next R0 will be incremented. So because R0 is 00, now we are incremented, that will get as 1. Now this R0 will be added to accumulator. Now accumulator contains how many values we are going to be iterated, that will be compared with the R0. So R0 will be compared with n, where n indicates up to what value we are going to add. If I given 5, we want to evaluate from 1 plus 2 plus 3 plus 4 plus 5. So every iteration, so initially R0 is equivalent to 0 initialized. Next we are going to be increment, that means 1 will be added to accumulator. Initial accumulator is 0, so 1 will be added. After this 2 will be fetched, it will be added. 3 will be fetched, it will be added. 4 will be fetched, it is added. 5 will be fetched, it will be added. So every iteration, what is the R0 value will become? 1, 2, 3, 4, 5. Every time we will check what is the R0 value. Whether it is equivalent to 5 transactions we want to do, or up to n is equivalent to 5 we want to do. We will compare this. If it is non-zero means not equal to, then go to loop 1. In the loop 1, we go for advancing to the next value, that will be added to accumulator. So this loop will be iterated until the R0 value starting from 1 to n value, it has to exist. Once these two values are done, if R0 content is equivalent to n, the condition fails, it will come out of the loop. So after addition, where the result is having accumulator. Now we will move this accumulator content into the target location, which is 70H. For that we will write move 70H comma A. So once this program is done, we can terminate the program by using HLB instruction. Now we will see the entire program at a glance. Origin we are giving as 0. N, what is the value of n, that we are going to give as a constant by using the equate directive. N equate 15. We will clear R0 register by using the instruction move R0 comma hash 00. Similarly, we will clear the accumulator by using clear accumulator. We want to add from 1 to n, so we will increment R1. This R0 value will be added to accumulator. Next, we will compare R0 with n, whether we have done the addition till n value or not. So for that, we will compare R0 with hash n by using CJNE, which stands for compare. First, it will compare R0 with n. If these two are not equal, then go to loop 1. Else, come out of the loop. So this loop will be iterated until R0 is equivalent to n. So this loop will be iterated till R0 is equivalent to n. When this condition is true, then we will terminate the program. Here, the result after addition we are having in accumulator. That accumulator contents we are going to be loaded into the target location by using the instruction move 70H comma A. So with this, all the values, it is a sum of n numbers, till n numbers you can take. So we can terminate the program by writing halt as lost instruction. Next, generate a program in 8051 to count a number of 0 bits available in byte available in external memory 1000H. So this is external memory. At 1000H, we have some data. I'll take as n. And store 0 RAM bit count in the internal memory location 60H. So this is external memory. This is 8051, in which we have internal memory. The objective of this program is given some value n. In this, we are going to have some binary format. We want to check how many bits are there with 0. How many bits are there with 0. So for this, we will shift or rotate the contents either towards left side or right side. For every iteration, one bit will be checked. When you rotate these contents, the content will be loaded into carry flag. If carry flag is equivalent to 0, we can go for incrementing the count. Count is equivalent to count plus 1. So like this, how many bits we have to check? Because the number is consist of 8 bits, the rotation will be takes place for 8 times, then 8 comparisons will be there. Now we will see the program. Move R7, 0AH, because we want to check 8 bits. So the number of bits we are going to be loaded into R7. As we are getting the data from the external memory, the address of the external memory will be loaded into DPTR. Then we will fetch the data from the external memory into accumulator by using MOVEX instruction. Whenever we are referring the external memory, we are going to use MOVEX instruction. So MOVEX accumulator, at the rate of DPTR. So now the external memory contents will be loaded into accumulator. Next, we are loading R0 with 60H because we want to store the result in 60H. So R0 will be loaded with 60H by using the instruction move R0, 60H. In this 60H, first we are going to be clear. So we will write move at the rate of R0, 00. Into that memory location, we are going to write 0. Next, we will rotate these contents towards left side. Either we can write RL or RLC or RR or RRC. Any instruction we can use. Either we can shift the contents towards left side or we can shift the contents towards right side. This shifting operation through rotate instructions either with carry or without carry, because there is no significance of carry here. To retain the same value, you can have RLC instruction. So this is accumulator contents. We are going to be shift this one towards left side. So each time, each and every bit will be shifted into the carry flag. Whichever it is in the LSB, that will be loaded into carry flag. Then we go for checking carry flag. Whenever this carry flag is equivalent to 0, then we go for incrementing. Otherwise, we go for skipping that increment. So when carry is equivalent to 1, because the bit is non-zero, go to loop 1. Here will come here. Suppose if this bit is 0, this condition fails, it will execute the next instruction. There we are going to increment the count. Next, how many times it has to iterate? Because it is 8 numbers, that is B0 to B7. For every bit check, decrement R7. If it is non-zero, go to loop 2. So this loop will be iterated 8 times. Once all the 8 bits are checked, our task is the count which is there in the R0 memory location, that we are going to be loaded into target memory location. So move R7, 08. 8 bits we are checking. The external memory address into DPTR by using the move instruction. The contents of the external memory will be loaded into the internal accumulator of 8051 by using the move X instruction A, at the rate of DPTR. Then the result we have to store into 60H location. So we will load R0 with the 60H. That memory will be cleared by using the instruction move at the rate of R0, 00H. Then we will rotate the contents towards left side of the accumulator. We will check for if carry is equivalent to 1, don't increment that memory location contents. Skip it. If carry is equivalent to 0, it indicates that particular bit is equivalent to 0. We want to find how many bits are 0. So go for incrementing the target location, that is 60H, by using the instruction INC at the rate of R0. So this loop has to be iterated until R7 is equivalent to 0. So for every iteration, decrement. If it is non-zero, go to loop 2. Again, shift the contents. Check for carry flag. So this will be iterated for 8 number of times. Once all the 8 times are done, how many bits are 0 are there, that we are updated in the 60H location indirectly with R0 register. So later we can terminate the program by using HLT instruction. Next, you will write a program to exchange lower nibble of the data present in external memory 6000H and 6001H. So in the external memory, here we have 6000H and 6001H. We want to swap the lower 4 bits. This is present in the external memory. Now you will see the program. Origin, where the program has to be stored, that we are given as org0000H. External memory address, we are going to be loaded into DPTR. So DPTR hash 00600H. This external memory contents, we are going to be loaded into accumulator. As it is external memory, we will use MOVX instruction. So MOVX a comma at the rate of DPTR. Then 45H will be loaded into R0, which is going to be point to the load pointer. So this accumulator contains whichever you have fetched into the 6000 location, that value we are going to be loaded into the internal memory, which is at 45H. So now the 45H location contents consist of the contents which is at 6000H location contents. Next, we want to swap with 6001H location. So the 6001H location for advancing it, so increment DPTR or increment DPTL. Then we will fetch the external memory, which is nothing but external memory 6001 location. This is some XY. This is some AB. This 6001H location, we are going to be loaded into accumulator. So the 6000 location is there in 45H. The second data, so D1 is in 45H. The D2 data is in accumulator. Now we want to swap the lower 4 bits. For swapping the lower 4 bits, we have XCHD. XCHD, that is exchange digit. When you have XCHD instruction, the accumulator lower 4 bits will be exchanged with the source contents. What we have source, which is 45H, where we have 6000H location. The lower 4 bits of 6000 will be exchanged with accumulator, but not with 6001. Later we will see that. So now this Y is swapped with accumulator contents. So now accumulator content is AB. So B will be sit here, Y will be placed here. So after executing this instruction, the contents of 6000 location contents previously, it is XY, which is in 45H, and 6001 location, which is AB, which is in accumulator. After executing this instruction, the 45H location will become XB and the accumulator contents will become AY. Now our task is these two contents again we have to load into the respective memory locations. So MOVX at the rate of DPTR comma A. Then decrement DPTR, because DPTR is pointing to 6001 location. So this contents which is in accumulator, this we are going to be loaded into 6001 location. Later we will go to 6000 location. So decrement DPTL. So into that memory location, we want to load the R0 contents, which is at 45H. So first 45H memory location contents will be loaded into accumulator. From the accumulator, it will be loaded into external memory by using MOVX at the rate of DPTR comma A. So with this, the 6000 location and the 6001 location of the external memory, the lower digit is exchanged. So we can terminate the program by using HLT instruction. So thank you. So in this session, we have discussed few programs related to 8051 microcontroller. Thank you.
like, share and subscribe. Hit the bell icon for more updates.